right, let's look at this one with the truck. All right, so let's imagine a truck here. And it said half the weight's on the rear and half the weight's on the front. So we'll draw here 500 kilograms. And here 500 kilograms. And that's for each of these wheels. All right, so here's the 500 kilograms for this wheel. And then we also have 500 kilograms for this wheel. And then it says, what's the magnitude of maximum acceleration it can achieve on dry concrete? So first, let's find out how much friction it can achieve, how much frictional force, because that'll be the maximum amount the amount of force that the tires can put on the road. So let's look at the friction equation. Force of friction is going to be force normal multiplied by mu. And we're going to assume that this is rubber wheels and dry concrete. And it says dry concrete right here even. And so if we look up the mu value of rubber on dry concrete, it's the maximum, it's 100% friction, it's right there. And that's static friction. You might be wondering, why is that static friction? Why is it not kinetic friction? I thought the tires were moving. Well, the tires are not moving relative to the road. They're not burning out, right? If the tires were rubbing against the road, that would be a burnout. And if they're just locking up with the road, they are connecting with the road in such a way that there's no rubbing or sliding going on, then we can call that static friction. So if there was sliding or rubbing, then you'd see smoke coming off the tires and stuff like that, and that would be a burnout. Okay, so we're not doing a burnout, although we could make a problem like that if you like. We could find out the acceleration while burning out, and that would be a little bit slower. But okay, so force normal. So with the force of friction, the force normal it's per tire, right? So there's a force normal here, and there's a force normal there. And so for the acceleration, we got to use just the drive wheels. Say 2 drive wheels, those in the rear for a truck, by the way. Okay, so force normal. Let's go off to the side here real quick. Force normal is mass times acceleration. Force normal is 500 times 10 meters per second squared is the acceleration due to gravity, so that's 5,000. Okay, so 5,000. And we just did a substitution here. So that's the substitution there. And then mu is just 1. We talked about that. It's 100% friction for rubber on dry concrete. So the force of friction is going to be 5,000 newtons. All right, so that's the maximum force we can obtain, but what about the maximum acceleration? So we can plug that back into force equals mass times acceleration. And we're accelerating the whole truck, even though the frictional force is only acting on the front wheels, because those are the drive wheels. So force is the mass, which is 1,000 times acceleration. And we got to put the force in there, which is 5,000 newtons. Divide both sides by 1,000, and we end up with the acceleration being 5 meters per second squared. All right, so I just going to recap on the small things really quick, the details that allow us to solve for this problem. Okay, first thing, the drive wheels are the red wheels. Those are the only wheels accelerating the truck. These wheels here are just cruising along. This wheel right here, that wheel is just cruising along. It's just going with the truck, but it's not providing any force on the ground. This is providing all the force on the ground, this red wheel. So we can't use the force normal being the whole truck, because the drive wheels or the only ones driving the car. So we just use 5,000 for the force normal. So right here, we just use the mass as 500, then we end up with the force normal being 5,000. So there we go, 5,000, we plug it into the force of friction equation, and we end up with 5,000 newtons. Then we end up with F equals ma, right? I'm looking right here now, and we end up with 5 meters per second squared. Now I think this is really interesting, because if we have all the wheels accelerating, well, we can sort that out real quick if you want. Force normal, well, then that's going to be 1,000 kilograms multiplied by acceleration due to gravity, which is 10. So the force normal would be 10,000. Then we find out force of friction would be 10,000 multiplied by 1. I'm just copying the same steps I did on the left. So F equals ma, and the force would be 10,000, and the mass is 1,000 times acceleration divided by 1,000 on both sides. And we get 10 meters per second squared. Now I find this really interesting. That's the maximum acceleration a car can achieve, period. No matter how big their engine is, doesn't matter. They could only accelerate at 10 meters per second squared. Now I'm like mind blown now, because that's kind of like a coincidence. So actually, it's not a coincidence. It's that's exactly gravity, isn't it? So if you were to go on Mars, have a supercar, 4-wheel drive, all 4 wheels on dry concrete, put some concrete up there, you could only accelerate at Mars gravity, which is less than 10 meters per second squared. Now, if you were to go to a different planet that has a higher gravity, maybe it's 20 meters per second squared, you'd weigh twice as much there, by the way. Instead of weighing, 150 pounds, you'd weigh 300 pounds, which would be really tough to walk. But anyway, if you were to go to that planet, get inside of a car that's super powerful, accelerate, you could accelerate at 20 meters per second squared, or 2 Gs. So there you go.